Hello everyone, my name is Sridhar and I am from CSEF section. And for complex engineering problem for probability and statistics, my topic is about sensitivity analysis of probabilistic safety margin in nuclear reactor cores. Here, let us discuss about the sensitivity analysis of probabilistic safety margins in nuclear reactor cores, such as uh, and now we are seeing the things such as where the introduction to probabilistic safety margins, which is also known as PSMs. Probabilistic safety margins (PSM) are quantitative and measures of how close a nuclear reactor is to safety limits under various conditions. They help assess the robustness for reactor safety system against the uncertainties and potential failures. Understanding and analyzing these margins are crucial for ensuring nuclear safety and optimizing reactor operation. Here we can see a graph which is showing that optimal balance between specificity and sensitivity. Here, like specificity, also known as the individual who do not have the condition. Sensitivity, the individual who have the condition, which are also to increase the sensitivity, shift to the left, and which to decrease the sensitivity, or shifting towards the right. Here we can see that uh, it is all about introduction to the probabilistics things, and then now let us discuss about the importance of uh, importance of the sensitivity analysis in PSMs. Sensitivity analysis identifies key variables that significantly influence safety margins. It helps prioritize areas for safety improvements and risk mitigations strategies. Conducting sensitivity analysis enhances the confidence in safety assessment and decision making processes. Here, which are most important to that sensitivity analysis, which is identifying the key variables that are significantly influence the safety margins, and also it helps in the prioritize areas for safety improvement, also risk mitigations. Let us discuss about the overview of nuclear reactor core safety. Here, the nuclear reactor core is the central component where nuclear fission occurs, which also generating the heat. Safety in the core involves controlling reactivity and managing heat removal efficiently. Various safety margins are established to prevent core damage and meltdown under the operational and accident conditions. Here, which are we are using the core reactor core, which is the most important and the central component where the nuclear fission occurs and which generating the heat, and there's also safety in the core, which involves in the most reactivity and also managing the heat removal efficiently. Probabilistic safety assessment PSA framework. PSA integrates probabilistic models to evaluate potential accident scenarios and their likelihoods. It quantifies the safety performance of nuclear reactors by analyzing the failure probabilistics. PSA supports regularity compliances and informs the safety related decision making. Here it is a PSA which frames out the things to be done. And now let us discuss about uh, sorry defining probabilistic safety margins. PSMs are also known as the probabilistic safety margins, measures the difference between the current planned condition and safety limits in probabilistic terms. They are derived from the probabilistic distribution of uncertain parameter affecting safety. PSMs provides a quantitative basis for assessing the margin to code damage during the various scenarios. And also, which are probabilistic safety margins are most important for uh, saving the nuclear reactor from uh, various things. And the methodologies for sensitivity analysis. Common methods includes local sensitivity analysis, such as derivatives and global techniques like Monte Carlo simulation, sensitivity indices such as Sobor indices quantify the contribution of each input variable to output variability. Selecting appropriate methods depends on the complexity of the models and the nature of the uncertainties, and also which are these are the most important things to the analyze the sensitivity analysis, which also makes the derivative like global techniques like Monte Carlo simulation. And now let us discuss about the key input parameters in core safety analysis. Here some of the key input parameters such as like parameter include neutron flux, coolant temperature, reactivity coefficients, and materialistic properties. Uncertainties in these inputs can significantly impact safety margin. Accurate characterization of these uncertainties is essential for meaningful sensitivity analysis. Here are some of the things which are like the key input parameters, which are like parameters like neutron flux, coolant temperature, and also reactivity efficiency, like coefficients. Now these things are like most important parameter for core safety analysis. And now let us discuss about the model uncertainties and their impact. Modern uncertainties arise from simplification, assumption, and limited data. Here, they can lead to a limited and assumption limited data. They can lead to the either overestimation or underestimation of the safety margin. Sensitivity analysis helps identify which model aspects most affect the safety assessment. Now, now let us discuss about the modern uncertainties which arises, and also these they can lead to the overestimation and underestimation of safety margin. This sensitivity analysis helps identify which model aspects most affects the safety assessment. And now let us discuss about the thing which is the case study sensitivity analysis in pressurized water reactor. A PWR safety margins were analyzed using Monte Carlo sampling of key parameters. Results identified coolant temperature and reactivity feedback as the most influential variables. This information guided target safety improvement and further research. And here, like some of the sensitivity analysis for the pressurized water reactor, where which is used for the safety margins, were analyzed it, using Monte Carlo sampling, which also now let us discuss about the result interpretation and safety implication. Sensitivity analysis results highlight which parameter require tighter control or more accurate measurement. Understanding parameter influence aids in risk for informed decision making. It also supports the development of more robust safety protocols. Safety, like sensitivity analysis, results in highlight which parameters require tighter control or more accurate measurement. Understanding this parameter influence aid in risk informed decision making. It also supports the development of more robust safety protocols. And then now let us discuss about the things such as challenges in sensitivity analysis. Here, some of the challenges in sensitivity analysis are high computational cost for complex, high-dimensional models can limit analysis scope. Uncertainty quantification depends on the quality of input and which may be limited. Interpreting the results require expertise and careful consideration of assumption. These are the assumptions which may take whether using the challenges in sensitivity analysis. And then now let's discuss about the uh, advances and future directions. Here, some of the advances and the future directions, such as integration of machine learning techniques, offers new avenues for efficient sensitivity analysis, and also development of hybrid models combines deterministic and probabilistic approaches for better accuracy. Ongoing research focuses on real-time sensitivity assessments during reactor operation. Here some of the things such as like integration of a machine learning things, which is most frequent nowadays for sensitive analysis, and also development of the hybrid models also mostly deterministic, and on ongoing research focus on real-time sensitivity assessment during reactor operations. And now the practical application and the regulatory aspects we're seeing by this side. Sensitivity analysis informs the safety margins used in licensing and regulatory reviews. It supports the development of safety cases and emergency preparedness plans. Regulatory bodies increasingly emphasize the probabilistic safety assessment as a part of licensing criteria. And this is all about the things which are like using here. And then now the summary and the key takeaways on some of the things such as like sensitivity analysis is vital for understanding the robustness of probabilistic safety margins, and also identifying the influential parameter helps prioritize the safety improvements. Continued advancement will enhance the safety and efficiency of nuclear reactor operation. And then some of the references like probabilistic safety assessment and risk management in nuclear power and nuclear safety. And this is all about the thing. Thank you.